Hi, my name is Giselle Artman, and today we'll be interviewing Lydiah Mairura in her renewable energy research on wearable solar energy devices. Let's go ahead and get into this interview.
My name is Lydiah Mairura. I'm an international student in the Department of Chemistry. I come from Kenya, in Africa. That is actually in East Africa. I work with Dr. Linkers in the Material Science Department in chemistry. Basically, what we are doing is the bigger picture is to have wearable devices that can convert solar energy to electrical energy. That is the bigger picture. We are using tungsten oxide as our semiconductor. So if you want to convert solar energy to electrical energy, you need a semiconductor. And we have chosen to work with tungsten oxide. So we have had other students work on, the semiconductor itself for us to be able to, to set up our cell. But then for my specific research, I am looking at the liquid that we need in that cell. So basically, you see the way solar panels are made, that is silicon, and it's just the panels is all solid. But then we have a different way that we can harvest the sun and convert that to electrical energy, and we use a photoelectrochemical cell. And that basically needs electrodes, like wires, and then it needs a liquid. And we are looking at making a very tiny thread that is basically a cell that can be part of our clothes, and just so that, for example, the coat I'm having right now could be having a few threads of that, so that if I walk out where there's light, it absorbs the light and converts that to electricity. And then we work on the connections, and then we can power our devices, phones, or maybe other things that could be connected to health. So my specific research, or my contribution to this research, is on the liquid part. Because we've had other people look at the electrode, look at the semiconductor. My research is on the liquid that we use. And this liquid is not just any liquid, it needs to be a redox couple. A redox couple is one that is able to do a forward reaction as well as a backward reaction. That means once the cell is set up, it just drives itself because it can go forward and backward. So the function of the liquid is to basically transfer charges from one electrode to another, because we're going to use 2 electrodes. So now the challenge we're having right now is that the most commonly used liquid, which is iodide solution, it's actually brown. So when the light gets in, it absorbs much of it. And you see, we need the semiconductor to absorb the light. And the worst part of it is that because the semiconductor does not absorb all the light from the sun, it has specific limits where it absorbs its light. But then our liquid also absorbs in the same limits. That means it's providing competition for the very, sun, the light we need from the sun to be converted to current. So my job is to figure out if we can find a better or a different liquid that can replace the iodide solution, whose absorption is outside these limits of tungsten oxide. So I have tried a couple of liquids here and there, and I discovered that if we use a quinone redox couple, that is basically benzoquinone, hydroquinone mixed together. Those ones, if you have that, then we have its absorption is outside the limits of tungsten oxide as our semiconductor. And because it's absorbing outside the limits, it means that tungsten oxide can now absorb the light from the sun without any competition. The more the light absorbed, the more the current produced. and the better our cell. So I have a background in chemistry and physics. And as I was doing this, I really fell in love with semiconductors. Initially, I was very curious with how semiconductors, the solar panels work. And when I had a chance to talk to Dr. Linkers and he gave me his dream, he explained to me the bigger picture, I just fell in love with it. And I'm kind of sad that I may not be here when the whole research is done and the whole thing comes, into fruition. But I am happy that I'm giving a contribution to this very nice invention that is coming up. Because I believe, for example, where I come from, we do not have like a lot of electricity everywhere. We have places that are really off-grid. And I can imagine what such an innovation can do to people if all you need is, just have your jacket, just have your top or your trouser that is able to absorb this sunlight. And we have sunlight basically the whole year, like back home. I mean, for me, it's a very cool innovation or invention that I would really want to see come into fruition.